Hello, welcome, traveler of the stars. Tonight we will gently untie the knots of the clock's hands to discover that the clock is not an absolute sentence. Did you know that quantum physics has recently shown that negative time is real and that light can leave a place before it has even fully entered it? In our everyday world, cause always comes before effect. But in the cold realm of atoms, photons sometimes ignore that rule and pass through matter while spending a strictly negative amount of time. If the universe itself can rewrite the order of events, what truly defines the present moment in which you now rest? On this journey, we will understand how scientists manage to capture this seemingly impossible phenomenon. We will explore experiments with atomic clouds and imagine a state of existence where past and future quietly exchange places. We will allow ourselves to feel the freedom of inhabiting a cosmos where linear time is only an illusion. Before we continue, I'd like to ask for a small moment of your support. If you find these explorations meaningful, consider subscribing to Cosmos for Rest, leaving a like, and sharing this story with someone who might also enjoy drifting through the universe with us. Your support helps keep this calm corner of science alive. Now settle in, close your eyes, and let science gently guide you. To begin understanding this story, we must first invite silence to sit beside us. Imagine that we are now inside an old observatory, one of those places made of stone and wood where the scent of aged books blends with the cool air of the night. Outside, the world continues in its restless rhythm, obedient to the constant ticking of clocks that govern our lives, the schedules of trains, the rising and setting of the sun. Since the day we were born, we learned a rule that seems unbreakable, as solid as the ground beneath our feet. Time is an arrow that points in only one direction. The past lies behind us, unchangeable like a statue carved in marble, and the future is a mist we have not yet touched. Between them exists this brief breath we call the present. That is our home. It is where we believe we live. For something to happen, 1 second must gently push the next, in a polite and orderly line of events. Cause and effect. First the seed, then the tree. First the thunder, then the echo. But now, take a slow breath and allow that certainty to dissolve like sugar in warm tea. The story I'm about to tell begins precisely when this fundamental rule, so obvious to us, decides not to work anymore. Let us travel in our minds to a modern laboratory, a temple of precision and quietness, where scientists, with the patience of monks, decided to question the very nature of duration itself. The setting is not filled with explosions or loud machines, but with light and cold, very cold. We are speaking of experiments that deal with atoms cooled to temperatures close to absolute zero. A level of calm so profound that even the natural chaos of matter seems to pause for a brief nap. It was in this environment of extreme control that quantum physics offered one of the most unsettling and poetic discoveries of recent years: the physical, tangible confirmation that negative time exists. This is not a literary metaphor or a trick of cinema. We are talking about light, the fastest messenger in the universe, behaving in a way that challenges our human logic. To understand where it all begins, we must look at light not merely as a beam cutting across the sky, but as a packet of energy, a traveler that sometimes carries with it a very peculiar clock. The origin of this mystery lies in the interaction between light and matter. Normally, when light passes through something, glass, water, or a cloud of gas, it slows down. It is as if the light must swim through a thick liquid. It interacts with atoms, greets each particle, pauses for a moment, and then continues its journey. That delay is expected. It is positive time, the time spent crossing a distance. If you walk from one side of a room to the other, you take a few seconds. That is natural. But physicists, in their tireless search for the edges of reality, began to wonder what would happen if light passed through atoms prepared in a very special way, arranged in a particular quantum state. The experiment that anchors our journey involves firing photons, those tiny particles of light, through a cloud of ultra-cold atoms. Imagine that cloud as a mist suspended in time, floating in a vacuum. When the photons enter this cloud, something extraordinary happens. Quantum theory had predicted it long ago, and now experiments have confirmed it. Under certain conditions, light does not simply fail to slow down. It appears to leave the cloud before it has even finished entering it. Let us visualize this slowly, because this is where the quiet magic begins. Imagine you are standing in front of an open doorway. To cross the threshold, you must take a step, place your body in the frame, and exit on the other side. A clock measures the time you spent crossing. Now imagine that, in this quantum world, the clock displays a negative number. That would mean you appeared on the other side of the doorway while you were still, in some mysterious way, approaching it. Your exit would occur before your entry was complete. Historically, this idea of negative time or negative group delay, as physicists call it, was debated for decades. Many believed it was merely a mathematical curiosity, a misunderstanding hidden inside equations that would never correspond to real physical events. After all, how could something spend less than 0 seconds completing a journey? Wouldn't that violate causality? Wouldn't it break the rule that nothing travels faster than light in a vacuum? Questions like these kept physicists awake through countless nights. Yet what we have discovered is that the phenomenon is real, and it does not violate Einstein's relativity. Instead, it expands our understanding of what it means for something to be somewhere, and when events truly happen. At the heart of this mystery lies the wave nature of light. Light is not just a tiny solid particle, it is also a wave, a vibration stretching through space. When this wave packet meets atoms, the interaction becomes so complex that the peak of the wave, the most intense part of the light, is reconstructed on the far side of the atomic barrier so efficiently that the measured travel time becomes negative. Pause for a moment and feel the weight of that discovery. It changes how we look at emptiness and matter. The opening scene of this narrative, then, is a laboratory where human intuition is left at the door, along with coats and umbrellas. Inside, beneath the glow of precise lasers and sensors, capable of detecting unimaginable fractions of a second, reality reveals itself to be far more flexible than we once believed. The beginning of this story is not merely the start of an experiment. It is the beginning of a new way of thinking about our own existence within time. Consider the delicacy required to measure such an effect. We are speaking of time differences so small that compared to them, the blink of an eye would last an eternity. Scientists had to build traps for atoms, using magnetic fields and lasers to calm the thermal dance of particles until they were almost motionless, creating a material medium perfectly tuned for this quantum ballet. It is a kind of cosmic craftsmanship. Every lens, every mirror, every beam of light had to be placed with absolute precision so that we could hear the universe whisper that time is not a prison. When we accept that negative time is a tangible physical reality, a door opens inside our minds. We begin to sense that the rigidity with which we plan our days, the anxiety we feel about passing minutes, may simply be a construction of our macroscopic scale. Deep down, in the intimate fabric of reality, the rules are gentler. Particles can borrow time. They can rewrite the chronology of their passage. This idea of negative time becomes, in a way, an invitation to deep relaxation. If light can free itself from the tyranny of waiting, if it can cross an obstacle without spending its precious time, perhaps tonight we can learn to do the same with our thoughts. The stage is set. A silent room, atoms floating in a cold vacuum, and a beam of light teaching us that the impossible is often nothing more than something we have not yet observed closely enough. This discovery is not only about physics, it is about perspective. For centuries, we looked at the clock as a strict master. Now science shows us that the clock is actually a flexible instrument, capable of bending under the subtle laws of quantum mechanics. The experiment carried out in Toronto, along with others that followed, did not invent negative time. They revealed it. It had always been there, hidden within the fine print of nature, waiting for us to develop the technology and the courage to find it. And so our journey begins not in chaos, but in the quiet order of a carefully controlled experiment. There, light, in its endless wisdom, shows us that reaching the other side does not always require spending time. Sometimes the universe quietly returns time we thought we would have to pay. With that feeling of gaining something mysterious and extra, we move forward, curious to see how this strange quantum behavior might echo within our own perception of life and routine. The stage is illuminated not by spotlights, but by soft lasers. And the performance we are about to witness is the gentle dance of time that seems to move backward, or perhaps the dance of time that never needed to run forward at all. Here science acts like a lantern in the mist, lighting a path where past and future briefly hold hands. And while you absorb that thought, allow your breathing to find its own rhythm, a rhythm that does not need to be measured, only felt. At the beginning of everything, there is no rush. Only the vast and quiet possibility that time, like us, sometimes needs rest. Now that we have stepped out of the heavy doors of that silent laboratory, I invite you to bring this fascinating strangeness into your own home, into the center of your routine, into the place where your life unfolds. At first, the cold atoms and precise lasers may seem far removed from the softness of your bed or the gentle glow of a lamp beside you, but the truth is that the border between cutting-edge science and your daily life is far thinner than we imagine. Physics does not happen only inside sterile laboratories. It happens in the dust that dances in a beam of sunlight, in the warmth of your blanket, and in the rhythm of your breathing. Everything is made from the same stardust. Everything follows the same hidden rules, including the newly confirmed rule that time itself can, occasionally, take a step backward. Now that we have left behind the heavy doors of that silent laboratory, I invite you to bring this fascinating strangeness into your own home, into the center of your routine, into the space where your life unfolds. At first, the cold atoms and precise lasers may seem very far from the softness of your bed or the gentle glow of a lamp that might still be shining beside you. But the truth is that the boundary between advanced science and your daily life is much thinner than we usually imagine. Physics does not happen only in sterile rooms. It happens in the dust that dances through a ray of sunlight, in the warmth of your blanket, and in the quiet rhythm of your breathing. Everything is made of the same stardust. Everything obeys the same hidden rules, including the newly confirmed rule that time can indeed take a step backward. Let us imagine how this reality of negative time might reveal itself in the experience of simple things. Think about the light that enters your window every morning. For us, it feels instantaneous. The sun rises and the room fills with brightness, but if we could slow our perception down to the scale of photons, we would see an epic journey unfolding. That light traveled through the vacuum of space, crossed the atmosphere, and finally encountered the glass of your window. According to what we now understand about negative time, something astonishing may be happening there in that transparent surface. While the light negotiates its passage through the atoms of silicon inside the glass, there exists a universe of interactions where the peak of that ray of sunlight may already be entering your room before it has completely finished crossing the solid barrier. It is an idea that subtly changes how we feel about the world around us. Look, or simply imagine, the objects surrounding you right now. The wood of a headboard, a glass of water, the walls protecting your rest. Everything appears solid, stable, fixed within the present moment. But on the quantum scale, all of it is a vibrant mist of probabilities. The experience of negative time invites us to notice that solidity itself is something of a macroscopic illusion. If the particles that form your body are capable of performing this strange feat, crossing barriers without spending time, then perhaps the weight of the day resting on your shoulders can also be crossed with a similar lightness. Perhaps you have already felt echoes of this strange physics within your own life, without ever having a name for it. Think about those rare moments of absolute flow, when you are deeply immersed in a book, in music, or in a calm and wandering thought, and suddenly the hours on the wall clock seem to lose their authority over you. The world outside continues moving. The hands of the clock keep advancing, but inside your experience, something different happens. You may live what feels like an eternity within a few minutes, or pass through hours as if they were only seconds. This elasticity of human perception is our biological mirror of negative time. It is almost as if our consciousness, built from the same quantum matter, intuitively knows how to bend the rigidity of chronology. In everyday life, we usually feel chained to causality. We wake up to work. We work to eat. We eat to live, one event always pushing the next. But the concept of negative time gently breaks this chain, at least within the quiet space of imagination. It suggests that a result might exist without the heavy cost of waiting. Imagine applying this idea to your rest tonight. Normally we think that we must spend 8 hours in order to earn rest. But what if the rest is already here? Available even before deep sleep arrives? What if relief could cross the barrier of your busy mind and reach your body before your thoughts have fully quieted? That would be negative time applied to the soul, comfort arriving before the cause. Let us bring this idea even closer. Think about intuition. How many times have you had the sensation of knowing something just before it happened? Turning a corner and somehow already expecting who you would meet. Science often explains these moments as coincidence or fast processing in the brain. But under the poetic light of quantum physics, we may play with another possibility. Perhaps somewhere within us, maybe inside a few electrons or photons moving through our neurons, a small part of the journey has already occurred. A tiny traveler may have brushed against the near future and returned, carrying a whisper of information before the event fully unfolds. Negative time allows us to imagine a universe where we are not blind to tomorrow, but gently connected to it. This perspective also reshapes our relationship with urgency. Modern society often overwhelms us with pressure. Everything must happen faster, sooner, immediately. Yet nature, in its quiet quantum wisdom, suggests that yesterday and tomorrow are more fluid than we think. If a photon does not need positive time to cross a cloud of atoms, then perhaps you do not need anxiety to cross your life. Nature's efficiency does not come from rushing. It comes from harmony. The photon does not run. It simply exists in a state where the obstacle no longer delays it. It flows. And that flow is exactly what we are gently searching for now as you settle deeper into your position of rest. Imagine your body as that cloud of ultra-cold atoms from the experiment. You are cooling your reactions, lowering the temperature of your emotions, letting the vibrations of the day slowly settle. You are becoming a perfectly calm medium, and peace is like that beam of light. It does not need to struggle to enter you. It does not need time to be processed or justified. In the realm of negative time, peace can cross every barrier, stress unfinished tasks, restless memories, and arrive quietly at your center. Before your next slow breath even begins, relaxation may already be waiting on the other side. That is the beauty of bringing physics into everyday life. It stops being a formula written on a chalkboard and becomes something closer to comfort. Knowing that the universe itself allows exceptions to the rigid arrow of time removes a certain weight from our shoulders. We are not machines slowly wearing down under the pressure of hours and minutes. We are made of light and atoms that know how to dance forward and backward along the timeline. Each time you close your eyes, in a sense, you are entering your own private quantum laboratory, a place where the rules of traffic, deadlines, and alarm clocks lose their authority. Think about listening to a melody. When you hear the first note, your mind is already anticipating the next one. There is an invisible bridge between the sound that exists now and the sound that will arrive a moment later. Music only makes sense because the past note and the future note coexist inside the present of your listening. That is an artistic experience of non-linear time. Negative time in physics is simply the material version of that musical experience. Matter itself is singing a song in which the ending of the phrase can appear beside the beginning. And as you internalize this, your nightly routine gains a quiet new meaning. Removing the clothes of the day, brushing your teeth, turning off the lights. These are no longer just mechanical steps marking the end of activity. They are gentle rituals preparing you to enter the negative time of dreams. Sleep is the place where chronology dissolves. Inside a dream, you can be a child and an adult at the same time. You can stand in two places at once. You can live through years within a few minutes. Dreaming is our daily visit to the quantum realm, and now we know that this realm is not merely a fantasy created by the mind. It has a physical echo in the behavior of light itself when it moves through extreme calm. Feel the air entering and leaving your lungs now. That rhythm is your most ancient biological clock, but try to notice the small pause between inhaling and exhaling, the brief moment where the air neither enters nor leaves. That quiet pause is where negative time lives, a moment outside of time. Allow that comfort to expand. There is no rush for the next breath. Your body already knows what to do. Your biology is wise and ancient, built from the same fundamental pieces that allow light to do what once seemed impossible. You do not need to understand the equations of quantum physics in order to live the truth of negative time. You only need to allow yourself to feel that you are not late for anything, that nothing has truly been lost. Time is not slipping through your fingers like sand. It is floating around you like warm water, supporting your weight, allowing you to swim in any direction, or simply float without effort while the universe quietly takes care of the movement. The experience of negative time is, in the end, the experience of freedom. The freedom of not being a prisoner of later. Let this scientific certainty cradle your rest. The physical universe, the real, measurable, testable universe, is far more magical than we were once told. It allows the effect to appear before the cause. It allows the answer to arrive before the question is fully spoken. And tonight, it allows rest to arrive even before you finish closing your eyes. Relax into the certainty that you are part of this beautiful mystery, and let the routine of the day dissolve into the vast and welcoming possibility of the eternal now. Let us now walk down from the surface and enter the hidden machinery behind this phenomenon. Until now, we have observed the glow of the discovery and the way it touches our imagination. Now, it is time to quietly look at the invisible gears that allow negative time to exist. How, after all, does light perform such a remarkable trick? To understand this, we need to adjust the lens of our mental microscope and observe the intimate relationship between matter and energy, where the rules of the game are written in the language of vibration and resonance. The deepest secret is not brute speed. Like a racing car attempting to break a record on a track, the secret lies in shape. To understand the mechanism of negative time, we must first imagine light not as a single solid particle, but as a pulse, a small packet of waves traveling together. Picture a long rope stretched tightly between two hands. If you give it a quick flick, a ripple moves along its length. That ripple has a form. It begins softly, rises into a peak, and then gently falls back into calm. Light travels in a similar way. like a small hill of energy sliding through space. Physicists call this structure a wave packet, or sometimes the envelope of the wave. Inside this packet, many frequencies are quietly mixed together, like a choir of different voices blending into a single powerful note. When this choir travels through empty space, every voice moves together, and the packet keeps its shape perfectly. The highest point of the wave, the peak of the energy, moves forward at the famous constant speed of light. Up to this point, everything behaves predictably, but the mystery begins when this packet of light encounters the special obstacle we described earlier, the cloud of ultra-cold atoms. Here we find the subtle strategy of nature. These atoms are not like a brick wall that simply blocks or reflects the light. They behave more like tuning forks, musical instruments that begin vibrating when they hear a specific tone. The atoms inside that cloud have been carefully prepared and tuned with extraordinary precision so that they resonate with the exact frequency of the incoming light. When the wave packet enters the cloud, a complex dance begins. The phenomenon responsible for negative time is known as pulse reshaping. This is where the quiet magic of physics unfolds. As the front edge of the light pulse touches the atoms begin responding immediately. Because of their prepared quantum state, they interact with each frequency inside the wave packet in slightly different ways. Some parts of the wave are strengthened, others are weakened. What emerges is a process of interference. You can imagine it as if the atoms are rearranging the line of people inside the wave. The back portion of the pulse, the trailing edge of that energy hill, becomes strongly weakened or absorbed. At the same time, the front portion becomes amplified through constructive interference. The result is extraordinary. The peak of the wave, the point we use to define where the light is, shifts forward. The mountain of light did not suddenly run faster. It was sculpted. Imagine a line of people waiting in a queue. If you suddenly remove several people from the back of the line and add a few new people at the front, the center of the crowd would appear to jump forward instantly, even though no one actually ran. This sculpting process causes the peak of the light pulse to emerge from the atomic cloud earlier than it would have if it had simply traveled through empty space. And that difference is what produces a negative value on the clock. Physicists measure the travel time based on the position of the wave's peak. If the peak appears sooner than expected, the calculation produces a number smaller than zero. Light, in a sense, borrows energy from the front of the wave and discards part of the back, creating the perfect physical illusion of time running backward. But the story becomes even more delicate when we look at the condition of the atoms themselves. For this effect to occur, the atoms must be almost completely motionless. They must be extremely cold, temperatures only a few millionths of a degree above absolute zero. In such deep cold, the natural thermal noise of the universe fades away. The restless vibration that usually fills matter becomes silent. It is a quantum stillness. Only in this profound quiet can light and matter interact with the clarity required to reshape time itself. This teaches us something subtle about the nature of extraordinary phenomena. Great wonders require great calm. Noise hides the magic. Silence reveals it. There is another important layer to this mechanism, the distinction between information and shape. When people first hear about negative time, they often imagine time travel paradoxes, sending messages to the past, changing events, rewriting history. But physics protects itself carefully. The speed associated with this negative delay, the speed of the wave's peak, can appear faster than light or even negative. Yet the true carrier of information, the very first sudden edge of the signal, never travels faster than light in a vacuum. Causality remains intact. The universe allows the shape of the wave to move in unusual ways, but the fundamental message inside the signal still obeys the cosmic speed limit. You might imagine it like an envelope and a letter. The envelope might appear to arrive early because of the reshaping of the wave, but the message written inside still respects the universal rules. Inside that atomic cloud, something even more fascinating occurs. For a brief moment, the photon and the atoms become a hybrid entity called a polariton, a mixture of light and matter. During this fleeting union, the properties of the photon and the atom blend together. It is within this embrace between pure energy and mass that time begins to bend. The atom lends its memory to the light, and the light lends its fluidity to the atom. If our eyes could perceive the quantum world directly, we might see that cloud of atoms breathing light. It inhales the future of the photon and exhales its past. Negative time arises from that gentle breathing. It is not an error. It is not a glitch in reality. It is a natural property of waves themselves. Any wave, in water, in sound, or in light, carries the potential to be reshaped. What the scientists did was simply create the perfect stage for this hidden property to reveal itself. The technical name for this phenomenon is anomalous dispersion. Normally, dispersion spreads waves out and slows them down. But in anomalous dispersion, the refractive index of the material changes so sharply with frequency that the group velocity of the wave can become extremely large, infinite, or even negative. It is as if the road through the material bends back upon itself, allowing the traveler to appear at the destination without crossing every moment in between. When we contemplate these mechanisms, we realize that reality is far more flexible than our everyday senses suggest. The solidity of time is merely a statistical average. Deep within the microscopic structure of matter, time behaves like soft clay, ready to be molded by interference and resonance. Atoms carry secrets that clocks cannot measure. They remind us that before and after are simply points along an endless wave, and the energy required to create this effect is surprisingly small. It does not require violent explosions or enormous power. It requires precision. It requires coherence. The light must be a laser, a perfectly organized beam where each photon moves in harmony with the others. This detail offers a powerful metaphor. Coherence allows transcendence. Disordered light, like the glow of an ordinary lamp, would scatter inside the atomic cloud and vanish. But coherent light, light that moves in unity, can cross the barrier and emerge before it finishes entering. The hidden stage of this phenomenon is therefore a world of extreme order and profound calm. The instruments used to measure it must be isolated from even the smallest disturbance. Footsteps in a hallway, traffic outside the building, even the faint vibrations of the earth itself. Any noise would break the delicate balance. Negative time is like a fragile flower that blooms only in perfect silence. And as we reflect on this, we may begin to wonder about our own inner mechanisms. If we are built from the same atoms, governed by the same quantum rules, perhaps small moments of negative time already occur within our own thoughts, our memories, or our dreams, too subtle for our instruments to detect. Perhaps the strange feeling of déjà vu, or the quiet intuition that something is about to happen, is a distant echo of these microscopic wave reshaping processes unfolding within the neurons of our brains. When we understand the mechanism, the wave sculpted forward, the atoms acting as artists of light, the deep cold allowing their conversation, negative time no longer feels absurd. Instead, it feels like a quiet symphony. A symphony in which the conductor may allow the final note to appear beside the opening chord, and where the silence between sounds is just as important as the music itself. Keep this image gently in your mind. Light being sculpted, the peak of a wave sliding forward while its tail remains behind, all of it unfolding in the frozen stillness of a vacuum chamber. This is how the universe softly tricks the clock. Not with force, not with violence, but with elegance, patience, and a deep understanding of its own hidden rules. Now we enter a territory where science begins to resemble something almost magical, a place where reality seems to guard its deepest secrets behind quiet doors, revealing them only to those patient enough to listen carefully. Until now, we have explored the setting and the mechanism. But within the phenomenon of negative time, there are still subtler mysteries, details that lived hidden inside equations for decades, quietly waiting for someone brave enough to look at them and say, "This is real." One of the first secrets lies in the act of measurement itself. In traditional quantum physics, there is a well-known principle. Measuring a system disturbs it. It is one of the fundamental dilemmas of the microscopic world. If you touch something to discover where it is, you inevitably push it. If you shine light on a particle to observe it, the very light you use alters its motion. For a long time, this seemed like an impossible barrier. How could scientists measure how long a photon spent inside the cloud of atoms without disturbing the delicate process itself? If they attempted to place a normal clock into the experiment, the quantum state would collapse. The fragile effect would disappear, and the mysterious negative time would vanish like mist. The solution that finally unlocked the door is one of the most elegant ideas in modern physics. It is called a weak measurement. Imagine that you want to know whether someone is sleeping inside a dark room. You cannot open the door, turn on the light, or make any noise. Instead, you quietly slide a thin sheet of paper under the door and observe the faint movement of air beneath it. The information you receive is vague, almost whisper-like. But if you repeat the observation many times, patterns begin to emerge. Slowly, a reliable picture forms, all without disturbing the sleeper. This is the spirit of a weak measurement. Instead of interrogating nature loudly, scientists ask very gentle questions. In the experiment, the polarization of light, the orientation of the light's oscillation, served as an extremely delicate clock hand. When the photon interacted with the atoms inside the cloud, it left an almost imperceptible mark on their quantum state, a small signature within the spin of the atoms. It was as if the photon briefly whispered a secret while passing by. Using instruments of extraordinary sensitivity, the scientists were able to listen to that whisper and reconstruct how long the interaction lasted. And this is where the most astonishing result appeared. The measured interaction time was negative. Not simply that the photons seemed to exit early, but that the time spent interacting with the atoms was mathematically less than zero. It sounds like a logical impossibility. How could two things interact for negative time? How could a conversation last -5 minutes? Yet the data consistently pointed in that direction. The interaction between light and matter was so perfectly tuned that the usual passage of time appeared to cancel itself. Instead of accumulating duration, the process effectively subtracted it. It was as if the universe had returned time to the system rather than charging it. Another hidden thread of this story connects the phenomenon to an older mystery of quantum physics, the tunneling effect. Quantum tunneling occurs when a particle passes through a barrier that, according to classical physics, it should never be able to cross. Imagine throwing a tennis ball at a solid concrete wall and watching it suddenly appear on the other side. For decades, physicists debated a subtle question: how long does tunneling take? Does the particle spend time inside the barrier? Does the crossing happen instantly? Or could it be something stranger still? The growing evidence now suggests that the tunneling time can also appear negative. Instead of struggling against the barrier in the present moment, the particle seems to take a brief detour through a strange mathematical dimension sometimes called imaginary time, emerging on the other side, having effectively erased the duration of the crossing. The barrier is not defeated through force. It is bypassed through a different relationship with time itself. There is also a delicate connection to the principle of borrowed energy within the quantum vacuum. According to the uncertainty principle, particles can temporarily borrow energy from empty space, as long as the debt is repaid extremely quickly. In a poetic sense, negative time behaves like the temporal version of that rule. Light briefly borrows time from the future. For an instant, the cosmic accounting ledger allows the balance to go negative, yet the harmony of the universe remains intact. Nothing breaks, nothing collapses. Reality simply adjusts. Another layer of mystery lies in the history of these ideas. For many years, the possibility of negative group delay or superluminal group velocity was treated as a mathematical curiosity. Some researchers who proposed these concepts were met with skepticism or quiet dismissal, yet the equations quietly continued to point toward the same strange conclusion. The difference between the speed of information and the speed of a wave's shape became the key. The message obeys the rules. The envelope that carries it can behave more freely. Nature had hidden the secret in plain sight, inside the subtle distinction between content and form. In this sense, the universe manages to be both rebellious and obedient at the same time. Another fascinating observation from the experiments is how robust the phenomenon appears to be. It is not a rare accident that occurs once in a million attempts. When the atomic cloud is prepared correctly, the negative delay appears consistently. The mystery transforms into a law. Light itself seems to prefer this elegant strategy. The deeper scientists looked, the more they discovered how sensitive the effect is to calm conditions. If the temperature of the atoms rises even slightly, just a few millionths of a degree, the coherence disappears and the time delay becomes positive again. Calm reveals the phenomenon. Agitation destroys it. The cold environment becomes a guardian of the temporal doorway. There is something almost poetic in this discovery. In the quietest places of the universe, time loosens its grip. Imagine the moment when researchers first saw the result appear on their screens. A measurement showing a negative value where only positive numbers had ever existed before. There must have been silence, confusion, careful verification of every cable, every laser, every calculation. Yet the result remained. A small negative number, repeating itself again and again. The universe had quietly spoken, and what it said was astonishing. Waiting, it turns out, can sometimes be less than nothing. The idea reshapes our understanding of the present moment. If negative time exists, then the present is not a razor-thin boundary separating past and future. It becomes more like a gentle blur, where both directions of time overlap and mingle. In that subtle region, the past and the future briefly hold hands. These experiments reveal that reality is not built from rigid chronological blocks, but from waves of possibility moving through space and time together. And the light that reaches your eyes even now may carry a small memory of that strange flexibility, a tiny surplus of saved time gathered somewhere along its journey. The mysteries of negative time are not meant to confuse us. They are meant to inspire wonder. They remind us that the universe still holds quiet rooms we have not yet explored, hidden attics of reality where the rules we learned do not fully apply. In those quiet places, light plays a gentle game with the clock, stepping out from its hiding place before the counting has even finished. And in that discovery, we are invited to accept something both humbling and beautiful. There is always more happening in the silence of the universe than our senses can hear. Just as a stone thrown into a calm lake creates ripples that travel outward until they touch distant shores, the discovery of negative time does not remain confined within the quiet walls of a laboratory. It spreads, it resonates, it connects with other regions of knowledge and with the vast structure of the universe itself. The strange behavior of light passing through a cloud of atoms becomes a small doorway into a much larger web of ideas, technologies, and possibilities. If until now we have focused on a single photon and its delicate journey through cold atoms, we can now widen our view and observe how this phenomenon quietly echoes across different layers of reality. One of the first places where these ripples appear is in the future of computation. We live in an age built upon the movement of information. Every message sent across the internet, every calculation performed by a computer, every signal moving through a network depends on the passage of time through circuits and processes. Even our fastest machines still operate under the discipline of sequential steps. One operation must finish before the next begins. It is a kind of orderly procession. But the discovery of negative time introduces a subtle possibility. If light itself can behave in ways that allow certain features of a signal to appear earlier than expected, then new forms of information processing may one day take advantage of this phenomenon. Researchers already explore technologies based on light rather than electricity, fields often called photonic computing. Instead of electrons moving through metal wires, pulses of light travel through carefully engineered materials. In such systems, the ability to reshape light pulses, the very mechanism behind negative delay, could allow information to be reorganized and transmitted with astonishing efficiency. The idea is not that computers would literally send messages to the past. Causality remains protected. But signals might be reshaped in ways that minimize waiting times within complex circuits, allowing systems to process streams of data with greater harmony and fluidity. In other words, machines could begin to think in a rhythm closer to the rhythm of light itself. Another fascinating connection emerges when we turn toward biology. Life has always been a master of subtle physical strategies. Long before humans learned to manipulate atoms with lasers, nature had already developed astonishingly efficient processes within the microscopic machinery of living cells. Consider photosynthesis. Inside every green leaf, photons arriving from the sun must travel through networks of molecules to reach a reaction center where their energy can be stored as chemical fuel. If that journey occurred randomly, much of the precious energy would be lost as heat along the way. Yet photosynthesis is extraordinarily efficient. Over the past decades, scientists have discovered that quantum effects may help guide this energy transfer. Instead of wandering blindly, the energy appears to explore many possible pathways simultaneously, selecting the most efficient route almost instantly. When we think about the principles behind negative time and pulse reshaping, we begin to wonder whether similar ideas might play subtle roles within biological systems. The molecules inside plants and algae are arranged with exquisite precision. They form environments where waves of energy can interfere, reinforce, and reorganize themselves. Nature may already be quietly using quantum strategies that resemble the ones we recreate in laboratories. The same physical laws that allow a photon to appear early on the far side of a cold atomic cloud also govern the delicate choreography inside every living cell. From the leaf, we can lift our gaze again toward the sky. Astronomy is another field where the understanding of light and time becomes crucial. When we observe distant stars and galaxies, we rely entirely on the light that reaches our telescopes. The timing and behavior of that light carry information about the structure of the universe itself. In extremely sensitive experiments, such as the detection of gravitational waves, lasers are sent along long tunnels to measure unimaginably tiny distortions of space. The precision required is astonishing. Scientists must account for even the smallest delays, distortions, or reshaping of the light signal. The deeper our understanding becomes of how light interacts with matter, the better we can interpret the signals arriving from the cosmos. In this sense, the study of negative time does not only reveal a strange laboratory curiosity, it sharpens the tools through which humanity listens to the universe. It helps us separate genuine cosmic signals from the subtle tricks that light itself may play along its journey. There is also a connection with one of the most mysterious objects known to physics: black holes. Near a black hole, gravity bends space and time to extreme degrees. Light itself struggles to escape the intense curvature of space-time. Theoretical physicists often study how waves and particles behave in such environments in order to understand the deep structure of reality. Phenomena such as negative delay and anomalous dispersion provide mathematical insights that sometimes echo within these extreme gravitational contexts. They remind us that the behavior of waves can be far richer than our everyday intuition suggests. The small experiment with atoms in a laboratory becomes, in a sense, a miniature theater where the universe rehearses its most subtle tricks. Another important ripple of this discovery spreads into the science of measurement itself. Modern civilization depends on extraordinarily precise clocks. Satellite navigation systems, communication networks, electrical grids, and scientific experiments all rely on the synchronization of time down to billionths of a second. When scientists observe unexpected delays or advances in the propagation of signals, they must understand exactly where those effects originate. Recognizing that negative group delays can occur in certain conditions allows engineers to refine the calibration of their instruments. What once might have appeared as a puzzling measurement error can now be understood as a real physical phenomenon. In this way, our collective sense of time becomes more accurate precisely because we have discovered that time can behave in unexpected ways. Yet beyond technology and engineering, the discovery also touches something more philosophical. Science does not only build machines, it shapes how humanity understands itself. For centuries, we imagined time as a rigid arrow moving forward with unstoppable certainty. That image influenced our sense of urgency, our planning, our fears about the future, and our regrets about the past. Quantum physics gently loosens that image. If at the microscopic level, the boundary between cause and effect can blur, even slightly, then the structure of reality is more flexible than our everyday language suggests. This does not mean the universe becomes chaotic or unpredictable. Instead, it reveals a deeper harmony beneath the surface. The laws of physics remain consistent, yet they allow behaviors that appear almost poetic when we first encounter them. A photon can emerge before it seems to have fully entered. A wave can reorganize itself so that the center arrives earlier than expected. The universe contains pathways where events unfold with surprising elegance. As we reflect on these connections between computation, biology, astronomy, and philosophy, we begin to see that no discovery truly stands alone. Knowledge spreads outward like those ripples across the water. The light that dances through a cold cloud of atoms in a laboratory is the same light that nourishes forests, carries messages through optical fibers, and travels across billions of light years from distant galaxies. And within that light lives a quiet lesson. Reality is not a rigid machine ticking forward second by second. It is a vast network of waves interacting, adjusting, and reshaping themselves across space and time. Understanding that network brings us closer to seeing the universe not as something distant or mechanical, but as something deeply interconnected. And within that immense web of interactions, every particle and every person participates in the same cosmic rhythm. When we bring our gaze back from distant stars and silent laboratories to the warmth of our own lives, something interesting happens. The discovery of negative time stops being only a technical curiosity and begins to touch something older inside the human experience, our long and complicated relationship with time itself. For as long as humans have existed, we have tried to understand time. The earliest civilizations looked to the sky and noticed the slow dance of the sun and the moon. From those cycles came the first calendars, carved into stone or drawn in the sand. Later came water clocks, sundials, mechanical gears, and eventually the atomic clocks that measure time with astonishing precision. Our entire civilization has grown around the idea that time moves forward in a straight and irreversible line. Morning becomes afternoon, childhood becomes adulthood, yesterday becomes tomorrow. This belief has shaped how we organize our lives. We speak of spending time, saving time, wasting time, running out of time. We build schedules and deadlines as if time were a scarce resource, slipping through our fingers like sand. Yet the discovery that light can behave as though it crosses a barrier in negative time introduces a gentle disturbance into this picture. It does not destroy the idea of time moving forward in our daily lives. But it reminds us that the deeper structure of reality is more flexible than our clocks suggest. At the smallest scales, the universe does not experience time in the rigid way our calendars describe it. Instead, time behaves more like a landscape than a straight road. In the landscape, there are valleys, hills, curves, and hidden paths. Sometimes the shortest route between two places is not the obvious straight line, but a subtle trail that winds quietly through the terrain. Negative time is like discovering one of those hidden trails. It suggests that the universe allows certain processes to reorganize themselves in ways that appear to shorten the journey through time. This idea resonates with something that artists, poets, and philosophers have sensed for centuries. Think about moments of deep joy. When we are fully immersed in music, in conversation, in love, or in creativity, time often seems to disappear. Hours pass as though they were minutes. The clock on the wall continues moving, but our internal sense of duration loosens. The same happens in moments of deep concentration or calm reflection. In those states, our minds seem to step outside the strict rhythm of the ticking clock. Modern physics does not claim that human consciousness literally bends time in the same way a photon does inside a quantum experiment. But it reveals that the rigidity we associate with time is not as fundamental as we once believed. Reality itself allows moments where the order of events becomes more fluid than intuition suggests. In this way, science quietly reconnects with insights that human cultures have expressed for thousands of years. Many ancient traditions describe time not as a straight line, but as a circle, a cycle, or a flowing river. The seasons returned. The stars repeated their patterns. Life moved through rhythms rather than through a single irreversible path. The industrial age introduced a different perspective. Factories required strict schedules. Trains demanded synchronized clocks. Productivity became tied to the measurement of minutes and hours. Time became something to manage, something to optimize. And with that transformation came a subtle pressure, the sense that we are always racing against the clock. Negative time, as revealed in quantum physics, does not remove that structure from modern society. But it gently reminds us that the universe itself is not bound by the same urgency we impose upon ourselves. Deep within the fabric of reality, time is not a tyrant. It is a flexible dimension that can stretch, compress, and occasionally behave in surprising ways. There is also a deeper philosophical comfort hidden in this discovery. Human beings often worry about the passage of time because it reminds us of change, aging, and eventually mortality. We imagine time as an unstoppable current carrying everything away. But if time at its most fundamental level is not strictly linear, then the story becomes more subtle. The information that composes the universe, the arrangement of particles, fields, and energies, does not simply vanish. It transforms, rearranges, and flows through different states. Our memories, our actions, and the traces we leave behind become part of the ongoing structure of the cosmos. In physics, information is rarely destroyed. It is redistributed. The photons leaving distant stars still carry messages from events that happened millions or billions of years ago. When we observe those photons through telescopes, we are receiving fragments of ancient stories written in light. The universe itself remembers. In that sense, every moment that has ever existed continues to echo in the structure of reality. Negative time does not mean we can travel freely into the past. The laws of causality still protect the consistency of events, but it reveals that the boundary between past and future is not as sharp as we once imagined. It is more like a gentle fog where waves of possibility overlap. Human culture has always been fascinated by this idea. Stories about time travel, prophecy, intuition, and destiny appear in myths and literature across the world. These stories reflect a deep curiosity about whether the future might somehow influence the present. Quantum physics does not confirm those myths in a literal sense, yet it does show that the microscopic world allows relationships between events that appear strangely symmetrical in time. Cause and effect remain intact, but their mathematical descriptions sometimes reveal surprising pathways. This realization encourages humility. The universe is far more intricate than the simple models we build in our minds. Every time science opens a new window into the structure of reality, we discover that our assumptions were only approximations. And that discovery is not frightening. It is liberating. It means that the world still contains mystery. It means that the story of the universe is not finished. For humanity, this is a beautiful reminder that knowledge grows like a living tree. Each generation adds new branches, exploring ideas that were once invisible. The discovery of negative time is one such branch. It invites us to reconsider the rigid framework through which we often experience our days. It suggests that beneath the surface of routine schedules and ticking clocks lies a deeper rhythm, a cosmic rhythm where waves of energy and matter move in patterns far richer than a simple arrow of time. And as we reflect on this idea, something inside us begins to relax. Perhaps we do not need to rush quite as much as we thought. Perhaps the universe itself is not in a hurry. When we turn our attention toward the horizon of what may come next, the discovery of negative time begins to look less like the end of an investigation and more like the opening of a long and fascinating path. Humanity stands at a moment similar to a traveler who has just discovered a new shoreline. We can hear the waves, we can feel the wind, but the ocean itself still stretches far beyond our sight. The experiments with cold atoms and carefully shaped pulses of light are only the first steps. They show that reality contains behaviors that our everyday intuition never suspected. And whenever science reveals something unexpected, it quietly expands the space of what might be possible. One of the most promising directions lies in the development of technologies based entirely on light. For centuries, our machines have relied on the movement of electrons through metal wires. Electricity became the foundation of industry, communication, and computation. Yet electrons encounter resistance. They produce heat. They slow down as they move through circuits. Light behaves differently. Photons travel without mass, and under the right conditions, they can move through materials with extraordinary efficiency. The discovery that the shape of a light pulse can be manipulated, allowing its peak to appear earlier than expected, hints at future devices where information flows with unprecedented harmony. Engineers already experiment with photonic circuits, tiny structures designed to guide light the way electronic chips guide electricity. In these circuits, pulses of light could be reshaped, synchronized, and directed in ways that reduce delays inside complex systems. Computers built on such principles might not simply operate faster, they might operate more smoothly. Instead of information waiting in long queues to be processed step by step, signals could be arranged so that multiple operations unfold in elegant coordination, each arriving at exactly the moment it is needed. The same ideas could influence communication networks. Today, the signals that travel through optical fibers across oceans already move at astonishing speeds. Yet even these signals encounter subtle delays as they pass through amplifiers, routers, and long chains of equipment. Understanding the physics behind pulse reshaping and negative delay could help engineers design systems that minimize those interruptions. The goal would not be to break the fundamental limit imposed by the speed of light in a vacuum, but to ensure that signals arrive with the least distortion and the greatest efficiency. In a world increasingly dependent on instantaneous communication, even small improvements can reshape how societies function. Beyond technology, another frontier lies in the exploration of extreme environments. The laboratory experiments that revealed negative time occur in highly controlled conditions, atoms cooled to temperatures near absolute zero, lasers tuned with exquisite precision, instruments shielded from the slightest vibration. But nature itself contains environments where extraordinary physics unfolds. Near neutron stars and black holes, gravity bends space and time so dramatically that the familiar structure of reality begins to warp. Light curves around massive objects. Clocks tick at different rates depending on where they are placed within the gravitational field. Physicists studying these environments constantly search for subtle effects that might reveal deeper layers of the universe's laws. The mathematical frameworks used to describe anomalous dispersion and negative group delay sometimes appear in these theoretical investigations. They remind researchers that waves and particles may behave in ways that challenge classical expectations. In this sense, the small atomic cloud inside a laboratory can serve as a miniature model of far grander cosmic phenomena. Another promising avenue of research concerns measurement itself. The weak measurement techniques developed to observe negative time have already begun to influence other areas of quantum science. These methods allow scientists to extract information from delicate systems without destroying the quantum states they are trying to study. This ability is extremely valuable in fields such as quantum computing and quantum communication, where fragile quantum states must be preserved long enough to perform useful operations. By refining these measurement strategies, researchers may learn how to observe quantum processes with increasing subtlety, listening to nature's whispers instead of interrupting them with loud questions. And beyond the laboratories, there is also a transformation that may occur within education and human understanding. Future generations may grow up learning from the beginning that time is not a rigid line, but a more intricate structure woven from interactions between waves, particles, and fields. Children who study physics decades from now may find the idea of flexible time as natural as we find the idea that Earth moves around the sun. When knowledge expands, our imagination expands with it. We begin to design technologies, societies, and even philosophies that reflect a deeper understanding of the universe. Perhaps the most important lesson offered by the discovery of negative time is not technological, but conceptual. It reminds us that the laws of nature often hide surprising possibilities beneath familiar appearances. For centuries, the motion of light seemed simple. It traveled forward, it slowed inside materials, and it obeyed the limits described by relativity. Now we know that even within those limits, light can reorganize itself in ways that appear to bend the ordinary flow of time. Nature does not violate its own rules. It simply reveals that those rules are richer and more subtle than we first imagined. And this pattern repeats again and again throughout the history of science. Every discovery opens new questions. Every explanation reveals deeper mysteries waiting beyond it. The universe invites curiosity. It rewards patience. And it often reveals its most beautiful secrets only after long periods of careful observation and quiet thought. As researchers continue exploring these phenomena, new experiments will appear, new materials will be developed, new techniques will allow light and matter to interact in ways we have not yet imagined. Perhaps future laboratories will create even more precise environments where the behavior of time can be explored with extraordinary clarity. Perhaps entirely new physical effects will emerge from those investigations. For now, we stand at the beginning of that journey. The discovery of negative time is not a final answer. It is an invitation to continue asking questions about the nature of reality. An invitation to remain curious about the hidden possibilities that exist within the quiet interactions of light and matter. And as we reflect on that future, something else becomes clear. Humanity's greatest strength has never been speed. It has been curiosity. As we slowly approach the end of this journey, it is time to let the lights of the laboratory fade gently into the distance. The instruments grow quiet. The lasers dim. The equations rest on the pages where scientists carefully wrote them. What remains now is not the complexity of the experiment, but the quiet understanding that emerged from it. We began with a simple question about time. For most of human history, time seemed obvious. It moved forward. One event followed another. Cause led to effect. The clock ticked, and the universe appeared to march along with it. Yet when physicists looked more closely, when they cooled atoms until their motion nearly stopped, when they guided light through those silent clouds with extraordinary precision, something unexpected appeared. Light could emerge before it seemed to finish entering. A pulse could cross a barrier while spending less than zero time inside it. Not because the laws of physics were broken, but because the deeper structure of those laws allowed waves to reshape themselves in ways our everyday intuition had never imagined. The discovery of negative time does not mean that the past can be rewritten or that messages can be sent backward through history. Causality remains safe within the architecture of the universe, but it does reveal something important. The flow of time is not as rigid as the ticking of a clock suggests. Deep within the microscopic interactions between light and matter, time behaves with a softness and flexibility that our daily experience rarely shows us. The universe, it seems, allows moments where the journey through time becomes shorter than expected, and there is something quietly comforting about that idea. All day long we live under the impression that time is something we are constantly losing. Minutes disappear into tasks. Hours slip into responsibilities. Days pass before we notice. But physics reminds us that time itself is not simply vanishing. It bends, it stretches, it reorganizes. Even the light arriving gently through your window has experienced a journey filled with subtle interactions and hidden complexities before reaching your eyes. And so tonight, as your thoughts become slower and your breathing finds a softer rhythm, there is no need to feel rushed. The universe itself is not rushing. Galaxies rotate over billions of years. Stars take millions of years to form and fade. Even the tiny atoms inside your body move according to rhythms far older than any clock humans have built. Within that immense calm, the strange discovery of negative time becomes a quiet reminder that reality is far richer and more generous than it first appears. The rules of nature do not trap us inside a rigid timeline. They allow waves to reshape themselves. They allow light to find elegant pathways. They allow moments where the expected order of events softens and becomes more fluid. And perhaps that is the most beautiful lesson hidden inside this scientific story. The universe is not a machine pushing us forward against our will. It is a vast ocean of interactions where matter and energy move together in patterns of astonishing elegance. Light travels, atoms resonate, waves interfere, and somewhere within that delicate choreography, time itself sometimes steps lightly outside the path we thought it always followed. As you rest now, imagine that gentle cosmic dance continuing quietly around you, photons crossing the darkness of space, atoms vibrating softly in the air, invisible waves carrying information through the world, all of it moving within the same flexible fabric of reality. You are part of that fabric. Every breath you take, every thought that passes through your mind, every cell in your body participates in the same physical universe where these discoveries unfold. There is no separation between the quiet experiments of scientists and the quiet moment you are experiencing now. It is all one continuous story. And in that story, time is not an enemy counting down the seconds. It is simply another dimension of the universe, one that occasionally reveals surprising and beautiful possibilities. Now, allow that idea to settle gently. There is nothing left to analyze, nothing left to solve. The journey of thought can slowly come to rest. Let the calm of the cosmos surround you. Let your breathing move naturally, without effort. And if you enjoy drifting through these quiet explorations of the universe, consider subscribing to Cosmos for Rest, where we continue sharing calm journeys through astronomy, physics, and the deeper mysteries of reality. For now, simply rest. The universe is vast. And tonight, time itself is in no hurry.